Ah, that's cool. So the session I did before was much more about the devices. And so it's specifically focused on Windows 10 IoT Core, really about, so Microsoft's platform for IoT. This session here is more about the services. And in fact, the demo I'm doing is going to be a Raspberry Pi Zero running Python and Linux, which is talking to Azure. And I'm going to show you a couple of projects that I've kind of got out there that might kind of give you some inspiration. So the focus behind this session is really probably these highlighted bits in here, as opposed to any kind of particular device things. So again, I think the thing that we talked about the last session was that the focus around Microsoft has really been around kind of enterprise capabilities, or building these things out to such a scale and all the kind of security, all those types of things that people can go and build and deploy real applications and know that they're secure and manageable and updatable and all those types of things. So to that end, we are building out a huge range of services up in Azure that are quite focused on IoT. And I'll talk about these. So the first one we have up there is IoT Hub. And the way I mostly think about it, it's kind of like a pub sub. You can push a whole lot of messages into it, and other people can subscribe to the events that are coming out of it. And you've got topics and all those types of things you can go and define. And it's a general purpose messaging hub for pushing in a lot of messages, ingesting a lot of messages, processing it, and pushing it out into the next part of the business process that it might be doing. Now, the thing that we've built on top of Event Hub is this thing called IoT Hub. And IoT Hub does a lot of the work that you could do it on Event Hub, but you'd have to go and do a lot of work around it. So we've done a whole lot of stuff around IoT Hub, which builds on top of Event Hub, but deals, for example, with all the provisioning of devices and the certificates for that, and managing that whole process, and the database which keeps all those devices in, and be able to bring them online, or maybe that device has gone rogue, so you want to be able to shut it down and not let any information come into your system. IoT Hub deals with all of that. So it provides a portal for mass, like internet scale ingestion of data ingestion. And you can horizontally partition. I think by default up to 32, or you can write to Microsoft and say, can I have more please? And you can define them up, I think 512, or a big size number of these partitions. And then you can have all these devices pushing these partitions, and you get vast scalability for these Internet of Things devices. You can imagine building out something which has just gone nuts, and you want to be able to get all that data into the system. There is, the other thing about this is it's priced at commodity. Now, I'm not going to go into pricing here, but if you go up into Azure, you go up into the pricing calculator, you go and say, look, I've got X number of messages, and you'll find that there's a free scale. So if you want to play around with this, you can go and register free of charge up on Azure for IoT Hub, and you get a 8,000 message subscription. So 8,000 messages per day subscription. And for playing around and getting your head around what's going, absolutely fine. You'd be amazed how quickly 8,000 messages goes though. You've only got to start sending them every like 10 to 20 seconds, and you have eaten up that 8,000 in the day. But just know that's out there. So you go up there, you register, you do have to put your credit card details in, but it's only for authorization. So it's only for identification. We're not going to take any money off you. If you go over that 8,000, you're not suddenly going to be charged on your credit card. It's absolutely locked at zero until you say, yeah, this is cool, and I want to take it to the next level. And there are a number of subscriptions out there, up to like, I think the next one there is 400,000 messages per day, and then there's, umpteen gazillion messages per day. I'm obviously exaggerating. There's a pricing calculator to go and check. So IoT Hub is really the fundamental building block for a lot of the IoT scenarios out there. Now, on top of that, there's obviously a huge range of services. And in fact, this slide, I think, is actually probably a year out of date, because you've only got to blink and to know that there's a new service come out for Azure. So the other ones I would talk about is Stream Analytics. Has anyone played around with Stream Analytics? Okay, so Stream Analytics, that's good, I can tell you anything. Stream Analytics, I think about it as real-time aggregation. So imagine you've got a system that's pumping in data. So you've got all these devices and sensors around inside your business that's pushing in data, and you kind of want to get a real-time sense of what's going on. What's the average temperature? What's happening in the water flow in a particular valve or something like that? And you're not interested in every one that's coming through at sub-second ingestion into IoT Hub. You might say, I'm actually really interested in the aggregate. So over a window, let's say we go and set up what's called a tumble window. You can set up like a tumble window of 5 minutes. And you might get a whole umpteen messages coming in that 5-minute window, and you want the average of what that sensor is. And then the next 5 minute, next 5 minute, next 5 minutes. So you can go and define these various types of window types, tumbling window types. So that's kind of what Stream Analytics is about. It's about the ability to kind of almost, in real time, be able to do data aggregation. And when you go and look at the language of Stream Analytics, it looks awfully like SQL, T-SQL. You got select statements, from statements, aggregate. It's basically a subset, I guess, of T-SQL. So if you're playing around with SQL on various platforms, you'll look at it and think, oh, yeah, I recognize that. And there's some great examples, all those kind of things. So that's what Stream Analytics is about. It's about you've got stacks of data coming in, and you want a way of just literally going into the UI and saying, this is my data point. This is where my data is being collected. That's my input for my Stream Analytics. This is where I want the data to go. And in the middle, I'm going to have some sort of query, some sort of aggregating query. It says, okay, every 5 minutes, all of that data comes in. I'm going to aggregate it, then I'm going to push you out one every 5 minutes. And that's your data every 5 minutes. So that's probably meaningful for your business. So that's what Stream Analytics is about. And on top of that, you can also use things like Power BI. And so Power BI, you can basically link it to an output from Stream Analytics and say, okay, I now go to Power BI. Does anyone play around with Power BI? Okay, cool. And you can basically, it's kind of an end user. It's not an end user, it's a business analyst tool. And you can go along there and map out graphs and all those types of things. And I'll show you kind of how that works. I kind of touched on the devices part, and I think for pretty much everyone was in here, so just talk about some of the security in there. And I've already talked about the editions in the last session. So that was the Enterprise Edition, Mobile Edition, and that was just kind of a bit of a recap for people who hadn't come along. Now, in terms of how you might think about architecting these things, and there are a number of ways in which you can go and build solutions that are kind of internet enabled. And it very much depends on your starting point. And in fact, that's where I spotted it. Because I remember thinking I hunted around for it. So there are a number of ways in which you get it. And you might have devices that you've in your business, and you might have had them there forever, or 30 years, or whatever. There's some historic investment in process control systems, and they talk protocols which maybe aren't necessarily such commonplace protocols now. And what you can do, what you can deploy out there is something we call a field gateway. So if you go hunting for IoT field gateway, it's a project up on GitHub, and you can download all the code, free to use it, and we have put in effectively bridges that bridge from things like the OPC. What we decided was OLE process control systems. CoAP is another one. These were protocols that were built for very small footprint devices, which really had very little processing capability, almost no memory, and a little bit of flash ROM. And they could just talk over a socket or whatever it might be to start doing things. So we've got these devices out there, typically historic devices, and you want some sort of way to be able to bridge those across into things like IoT Hub. So the field gateway is your friend, and it's got all the source code out there, and there's lots of examples out there, and you can go out and build things. And we've got examples out there for MQTT, CoAP, or Join, which I showed before, and things like that. And those are basic providers. And then on the other side of that, you can basically say, look, I want to go and talk to IoT Hub. And for example, IoT Hub, as its main protocol, is this thing called AMQP. And the S, I think, stands for secure. And it's Advanced Message Queue Protocol System. Security. Oh, gosh, hang on a second. Someone's trying to ring me. Okay, so that is, and it's an industry protocol. Interesting enough, Amazon use it as well. So it's a protocol that's kind of recognized across the industry. People like it, it's nice and scalable. It works very well in multi-tenant environments across cloud environments, things like that. Apologies. So these platforms here can bridge across into probably AMQPS, or you might have other platforms out there. And the other really popular protocol that's been out in the wild for a long time is this thing called MQTT. Has anyone spotted this? Use these? Okay, so it's now interesting. Does anyone know where MQTT came from? It's actually an IBM protocol. And it came out of their process control systems. So believe it or not, that's where it came from. And IBM have a system called Message Queue, and this was their client. And that's Message Queue telemetry, telemetry transport. And it's basically over a socket, and there's a bit of a connection, and you can do guaranteed delivery and acknowledgement, all those types of things built into the protocol. And so it's a protocol that you find in a lot of places as well. You do find that particularly things like Arduino projects and process control systems, all the way down there, you'll find MQTT, CoAP, all these types of protocols in these quite small systems. We, as of about 6 months ago, now natively support MQTT as well. So if you've got historic systems out there using MQTT and you want to bridge that across or can have that connected into IoT Hub, we support those protocols natively into IoT Hub. The other protocol that we support, hardly surprising, is HTTPS. So you might say, look, the only thing I can do is I've got just enough resources, and actually you probably need quite a few resources, to go and talk HTTPS. And you can do a what is it? It's probably a put. You can do HTTP put, and you can push the information. Is that right? You do a put? You do a put and a post, wouldn't you? Yep. And the way in which you get, if you want to do command and control, you basically poll. You go up there and say, is there a new message? No, there's not. Is there a new message? No, there's not. Yes, there is. And blah, blah, blah. And then you start, turn the valve off and things like that. It's not the most scalable approach using HTTP. And I think the recommendation was, and I don't know why this is, but the recommendation was you poll around about every 20 minutes. Now, why is it 30 minutes, not 30 minutes? Why is it not 15? The product group kind of said, you should think about 20 minutes. Whereas these MQTT and AMQPS, they're kind of more session-based, and you can send a message straight down, and then you can have your system immediately respond to that message that's come through. And as I said before, down here we deal with things like device management, provisioning, and identity, and security, and all those types of things. And they obviously provide a mechanism by which to get out that data at the other end. So that's kind of what the IoT Hub is about. So it's about providing effectively this bucket of capability of ingesting messages, making sure they're secure, making sure the device is valid inside that system, and then being able to get out that information at the other end. Now, the thing about what we're doing around IoT Hub is we want to make sure that it's applicable across a wide range of platforms. So not just Windows 10 IoT or not just the Microsoft ecosystem. We want it to be everywhere. To that end, we have open sourced the Azure IoT, it's called the Azure IoT SDK. And in that, you can download all that, and you can build pretty much any platform out there. There is an SDK for it. And I've actually also done a couple that are not on here. Does anyone play around with the ESP8266? And I've got one here in my bag somewhere. Yeah. So if you go up to my GitHub, so github.com/gloveboxes, this chip on here is actually a really popular one. It started in the maker community, but you're also seeing real product coming out of it. Just to give you an example about commoditization, this is chip here, which came out of China, and it's Arduino compatible. It's also got built-in Wi-Fi, and it's got enough memory in there to be able to do HTTPS. And for an embedded device for a couple of bucks, it's amazing that you can do HTTPS and secure transactions from this little device here. Hook up it's got Wi-Fi built into it. You can put sensors on it, and you can see I've got a little BMP 280, which is a little temperature, air pressure, and humidity sensor on it. And I could HTTP push that up into Azure, and it's fully secured. So really quite remarkable. You can do it from a device that's as small as this. Now, the demo that I'm going to do, I have to say, I've been in Microsoft for over 20 years, and this is the first time I've actually done a Linux and Python demo. And I've been kind of getting more and more into Raspberry Pi and Linux, and I've actually kind of been finding my way around it. So on my desk here, I've got a Raspberry Pi Zero. Has anyone seen the Raspberry Pi Zeros? They're like, now in Australia, they cost you about $30. But if you buy them from the UK, and you're prepared to pay like $10 shipping, you can get them from a company called Primorian, I think they call themselves. And they're like hen's teeth, very difficult to get hold of. But you can get hold of these devices for about $10, plus another $10 to shipping. So you can get about $20. And they're quite a nice little system. And they run Linux on them, and you can go and run, and I run Mono on them. So Mono is the open source version of .NET, and I kid not, I do run a reasonably sophisticated system on Mono on this style of device. But obviously you can go and play around with Linux and Python in this case. So what we've done is that we've delivered a C++ Azure SDK, and of which you git clone it onto your Raspberry Pi. You might think, why would I do that? You do it, and then you have the joy of compiling the C++ library on the Raspberry Pi. And basically you kind of get it running and you go to bed. And in the morning you wake up and the compiler's completed. I think it probably takes maybe 2 to 3 hours, maybe a couple of hours. I literally did go to bed. And then so it goes and compiles up all the libraries for you. And then you go and compile up the C libraries, the Python libraries, which basically talk on top of those C libraries. And that's how you get it. And then once you've got that up and running, you've got a Python platform where you can now start talking to Azure. Now, the way that I like to do these ones is I use a product that's free of charge out on the web. It's called Bitwise. And it's a nice little client which can talk SSH and SFTP. And so what I've got here is you can see that from Windows, I can use code, which is kind of a nice platform. So just to be clear, I could equally remote terminal to this, or I could plug in a keyboard and things like that, and I could use the Python editor on the Raspberry Pi, but it's really, you've got to be patient, because it's a slow platform. Or I can go and use it the way I'm doing it over SHTTP, and I can bring it into code, and then I've got this kind of nice platform, and I could even go and execute the Python code on Windows, get it all working, then push it across onto the Raspberry Pi, and it can be much more productive. And you can see down here that I've got a key. Now, I'm just jumping around a bit, so apologies. I'm going to jump around. So step back from that. So what I've also installed on this desktop is something called Device Explorer. And again, you can get Device Explorer off the IoT SDK site. And the Device Explorer is not a product that you would ship. It's an SDK, and we provide all the software for it. And you would actually go and embed the technology that we put into the software into your product. You would go and build a portal for managing your devices, and you'd use the calls, and you can go through this code and say, okay, that's how I can register a device, that's how I delete it, that's how I disable it, that's how I go and set security on, all that type of thing. So this is what this product is. It's not a product, it's an SDK, it's a demonstrator. And you remember before that I said that you need to go and register devices. And there's a UI in there, and we can go and call it, I don't know, NDC Sydney. NDC Sydney. And what that would do is that it would put it into the device registry inside IoT Hub, and you would see that there goes my NDC Sydney, and I could right mouse click on it, and I could get the connection string. And that's exactly what I've done down here. So you'll find one below it, and you'll see if I copy that, that's how I get the connection string. And if I go back to my Python code, I copied and pasted my connection string into there. And that's where I got it. And then that'll go and the code will go and look at that. Now, some of you might be thinking, heck, he's just deployed a solution with a hard-coded connection string in it. So we are actually bringing out a connection service, connection string service, for want of better words. So you better manage that. So rather, you better manage if you need to update it or whatever you need to get rid of it or update it or change it or whatever you need to go and do, you can go and do that. But in this case here, you can see I've actually put the code into the application. And then there's some stuff there around services, and then basically it just sits down here in a loop. And I've got a hat. So in the Raspberry Pi world, you call them hats. Does anyone know what it stands for? It's got a weird thing like hardware attached on top. I think it's what a hat stands for. And there is a specification. So Arduinos have shields. Raspberry Pis have hats. That's kind of it. And in this hat, there is a temperature and a barometer, and actually a light sensor in there as well, and a motion sensor, so you can kind of figure out which way it's going. Just some basic sensors. And you'll see down here that when I installed the Linux libraries for this EnviroFat, in fact they call it, I get access to a library. If I just scroll back up the top here, it's called EnviroFat, and I'm importing the light, the weather, and the LEDs. And if I scroll down back here, you'll see that there goes the pressure, there goes the weather temperature, and there goes the light level. So that's kind of what's going on there. So, and then below that, you'll see I just convert it to JSON and push the message. Actually, that's the method there to go and send the message out. Excuse me. So that's kind of how it's working. So it's amazing. So it could be across all those platforms that I showed you. We provide SDKs, and this example here I've just used a Raspberry Pi. But you can do it across a whole range of platforms. They're non-Microsoft, they could be C++, embedded systems, they can be Linux systems, like Windows systems, whatever. We've provided a huge SDK, and you can get out there and build things. Now, he says losing his voice. If I go back to this Device Explorer, and remember, this is just for your own development purposes. It's not something used for production. Excuse me. So what you can see now is those are the items that are coming from this Raspberry Pi. So this Raspberry Pi over Wi-Fi is bridged onto my phone, and from the phone it's bridged out into the internet. So I'm just using a hotspot on my phone. And you'll see that if I go and cover, so the light level, there goes light at 42. If I go and cover that, you'll see it drops down to 0. And it'll pop back up to 42. So it's real-time data. And so as I said, that data is running on a Linux-based system. It's using the C++ SDK. And we've provided a Python library, and in this case, I've gone and compiled it up. So that's kind of how that's working. And up here, there is also very rudimentary example, and it's really, again, just provided so you can kind of see what's going on. And if I jump back over to the dashboard, and if I change to scripts, I normally do it like this. So I think I've hopefully just rebooted that. And if I come over here and said, hello, not that it matters with a typo. It's hello world. And in there goes my spelling mistake. So there goes that message that got sent from Azure Hub. This device here had subscribed to the messages, and the message came down. And obviously I would use it to go and change the state of something that was connected up to this Raspberry Pi. Turn a valve on, turn a light on, whatever it was, change the rate in which you go measuring. It could be whatever, things like that. And you'll also see is that so what it's doing is it's sending a message, and I'm getting a confirmation back from Azure IoT Hub to say, yep, got the message. And you could obviously go and change the behavior of your app if it wasn't connecting or do things like that. So there we are. I've done my first demo ever on Python and Raspberry Pi and Linux. And it works really quite surprisingly well. It's very good. I'm a bit of a fan of the Linux Raspberry, I have to say. It's basically Debian Linux. So that's an example there of how that all works. Now, in terms of tools that I use, by the way, if you're going to be doing some of the stuff with Linux and you're using Windows development environment, there are a couple of really useful tools, and it might surprise you the source of these tools. So one of them is actually a really good application in Windows 10 Store, and it's called All My LAN. And basically Linux uses something called MDNS, and it's multicast DNS. And it's a way in which it goes and broadcasts. This is who I am, this is where my address is, this is how you can find me. And it's really useful because if you don't have that there, you put a device on the network and you want to SSH into it, you've got to find the address of it and all that kind of stuff. It's a really useful way. I used to like bring up my home router, go down my router, find out, oh, that's the DHCP address it's got, and then kind of get jumped to that way. But this is a really useful tool. The other really useful tool is something called, is an Apple product. And I actually use the Apple Print Bonjour application, because Bonjour is actually an MDNS client. And if you install that onto Windows, then Windows now becomes, it can resolve across the whole platform. And so you can go and, so you'll see that I often, inside this application over here, you'll see, if you were very keen of sight, it's Raspberry Pi 0 sh.local, and it's actually Bonjour, the Apple product, which is actually doing the name resolution, and it makes it much easier to work with. Otherwise, you've got to hack around with IP addresses forever. It feels like forever. Okay, so that was the main bit of that demo. So the next thing I'm going to talk about is Stream Analytics. Now, I've kind of touched upon that already. It's kind of this real-time capability. And the next thing I'm going to talk about is Power BI. So what I'm going to do is jump into Azure. Has everyone played around with Azure? Yep, cool, great. Okay, so all I want to do is I created a new resource, or a new job, called a Stream Analytics. And you define an input, you define an output, and you define a query. So in the input over here, I defined it to be IoT Hub. The IoT Hub could live in my current subscription, or it could be in another subscription and I've got the keys to it. So you can do it like that. The output, in this case, I could maybe push it onto another process, maybe a Logic app or something like that. But what I'm going to do is I'm going to push it into Power BI. And I'll show you how that works. And then I define a query. And as I said before, if you've done any SQL, and I suspect most of us have had that joy or pain, it looks an awful lot like SQL. You've got select statements and froms and intos and group bys. And you remember I mentioned about these things called a tumble window? A tumble window, in this case, I've got 30 seconds. So I'm interested in all the telemetry comes up, and I'm going to chunk it up into 30 seconds. And get the, in this case here, you can see I'm getting the average temperature, average humidity, light and air pressure, and I wanted to know what the what's this one here? The date of that one. Now, in this example, I've actually dealt with a problem that I tried a multitude of ways to get around. And in the end, I found a very simple solution. One of the biggest challenges with IoT is time, being able to get at the time. So I've spent probably way too much time working with NTP or real-time clocks on these things so that this type of thing has a sense of time. The other way you can do it, depending on what your business requirements are, you could say, well, actually, I don't care about what time's on the device. It's not that interesting to me. What I am interested in is the time that it got enqueued into IoT Hub, which is probably going to be roughly the same time. So that's what I've done. So I moved away from trying to get time correct on the device to saying, actually, I'm just interested in the time that reaches that device, that reaches IoT Hub. So that's one of the things there. So, and I did dig around in this, and basically you can go and you can see it's called event enqueued UTC time. And it's just a nice way of dealing with time, because time and invariably in IoT is a pain. Has anyone else taken that approach? Or you try to put time onto the device? Some devices, they just need to know the time, because they're going to schedule something locally and you want to do it at a particular time. But for maybe a lot of sensor scenarios, Actually, time's not that important on the device. So that's kind of what we've got there. So, and then I've basically created that job and started up, and it's just processing it. The only thing that's streaming data to that portal at the moment, I think it is, and someone's out there doing it, is this Raspberry Pi. And the next thing I'm going to do, and I have to say I didn't get really too much of a chance to go and check this. And I'm pretty sure that's not what it's called. Slightly worries me because, doesn't matter, I'm just going to talk you through it. So the reason I think I've actually mucked up my Stream Analytics job, and I think I've just misdefined a name. Because I know data is going into the hub, because I can see it from the IoT Explorer, and I know the data's been processed, I think I've made a typo in terms of one of the names. Because what I would expect to see is down here a data set named Raspberry Pi 0, and there isn't one. So it just means I've screwed up somewhere. So for the want of this demo, I'll just keep going a little bit because I've got another data set, except I know the data's not real. And there may be no data showing up. So out from the output of that query, if I just jump back over here, go over to the query, you can see I've got Celsius, humidity, light, blah, 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 and device ID and geolocation. And if I come across to Power BI, all those fields will automatically appear when it's working correctly. They will appear in this drop-down menu. And then it just becomes a matter of saying, now how is I going to do this? Apologies for this. So I would come across here and select my chart type. And let's just say I want a line chart. Come across there, and how do I do this again? I say time created is on the axes. And I say the device ID goes on the legend. And let's say its temperature goes on values. And because there's no data going in there. But you kind of get the idea that you can then, in fact, there is some data, but it looks to be old data, I suspect. There's one flat line. And because it's probably old data that I've got in there. But you can see that Power BI gives you this capability to literally, inside a web browser, go and define a report. And look at that data. So remember that data's coming from all your vast array of Internet of Things devices. They're getting pushed into IoT Hub. It's been summarized in real time by Stream Analytics, and then the output of that is going into Power BI. And clearly Power BI is not interested in the millisecond data. It's probably interested in hourly or weekly or daily kind of aggregates. And that's kind of what this tool's about. And it gives you a very nice view of doing that. There is a desktop version of the Power BI Designer as well, but from memory, it doesn't support data coming out of Stream Analytics. Certainly didn't when I last looked at it. So that's kind of this whole end-to-end scenario. Now, a few of you might be thinking that's hard work, and which is going to lend on to my next part of my talk. And what we have done, because we kind of figured that most people want to go and do not too dissimilar capabilities. What we've brought out is something called the the Azure IoT Suite. Now, the Azure IoT Suite is effectively a bundling, for want of a better word, of the services like IoT Hub, Stream Analytics, Power BI. I think there's machine learning, there's Cortana APIs in there, all those types of things you go and use to go and build out a service. So in that IoT Suite, there is basically a starter kit to say, look, fundamentally, there are a couple of scenarios that we support, and I'll show you that in a second. There are 2 scenarios that we support. We support remote monitoring. So you go and literally click on that and say, I want to provision a remote monitoring. And it brings up a generic remote monitoring with a couple of generic sensors. And then you go and change the Stream Analytics queries based on the data that you've got coming through. And you go and change a few things in there. And we provide you the framework and all the nice things that I showed you. Remember I showed you that device explorer, pretty cluggy kind of thing? Well, this is the kind of the commercial version. So you can say, look, Microsoft, most of my solution looks like that. I'm just going to take one of those. The other one that we've done is we've done this thing called predictive maintenance. And again, we kind of view that as a really popular scenario. People are interested in, if something changes, I'm getting a whole stream of data coming through, and maybe I've got a vibration detection. Then maybe that would be an obvious thing that would say, okay, maybe I'm running a lift system. I'm getting vibrations in the motors or the escalators or whatever it might be. That data comes through, and then you can do things like automatic events and alerts and notifications, all those types of things, and tracking your data. So we basically provide kind of 2 scenarios, and we're going to build on those and kind of create out more as well. So IoT Suite, the remote monitoring scenario out of those 2 that I just showed you, this is kind of a bit of a screen snapshot of it. So you can go and geotag your data, have it visualized. You can see which sensors are sending them. You can go on various charts and all those types of things. So again, this is the kind of idea that maybe you're building for your own enterprise, or maybe you're a partner and you're building out you're an ISV, I should say, and you're building out a product that you're going to go to market with. And you're selling this, and then X number of customers say, look, can you tweak this, can you tweak that? And you've got a basic framework to go out there and build on. So that's what the IoT Suite is. And again, this is just another screenshot of all the devices out there, the metadata that you keep with their devices and things like that, what platforms, what versions, what SDKs they're using, and things like that. And that's pretty much it. So hopefully it gives you a sense of IoT Hub there is to make it easy for mass ingestion of data, typically in IoT scenarios, but there are a lot of scenarios which kind of encompass IoT. You can go and build stuff yourself. So we're putting all the building blocks on there. So you've got IoT Hub, you've got machine learning, you've got Stream Analytics, you've got Power BI, you've got blob storage for saving data, all those types of things. Or you could say, well, heck, actually Microsoft's already invested that. There's a cost to using IoT Suite, a usage cost. You might say, well, actually, it's just worthwhile. I'll just go and use the one that's there, and I'll go and customize it. And do it. And all the source code's provided. You can go and do with what you want. So hopefully it gives you a sense. And as I said, I demonstrated the Raspberry Pi, Linux, talking Python, talking about so wide range of platforms out there. And it really is genuinely, it's really quite an astonishing set of devices that we support. If I can find my slide. That one there. So kind of getting back to there really is a huge range. And I see these being used by startups and organizations, all these platforms. There's some really amazing set of technologies. And that's pretty much it. So are there any questions? All right. So where do you think the intellectual property? Well, I mean, Yep. I guess the reality is some IP is commodity. It's been commoditized. So we could argue, the value of that. There are some people, and then there is going to be some intellectual property which hasn't been commoditized, and there's real value in it. So I think that's what's going on. The world's changed from what it was 5 years ago. Operating systems and core, and you can see what Microsoft's doing as well. You can see what's happening in the Linux world. You can see what's happening in the Apple world, where they make the money on hardware, not on kind of the software so much. So you can kind of see that change. And I think it really comes down to us to find what is going to be our unique selling point and how we put those building blocks together and come up with some solutions. Yeah.
What, if any, is, I guess, Microsoft's view on Industry 4.0 and IoT? Are they just seen as the same thing, or
I'm not sure I can comment. Yeah, sorry.
And are you aware of the feature of connectors? Has it been like shut down or
Of client actors?
Connect, the Microsoft Connect device, Xbox Connect? That
Oh, Connect. Oh, yeah. Oh, no, absolutely. That's still absolutely there. Oh, yeah. Yeah, we've changed the bundling, all that kind of stuff, because I think we put it with the Xbox One, and it made us $100 more expensive than Sony. So then we kind of, market forces dictated that we unbundle them. Yep. Yep. In fact, you can get your Xbox S, I think, pretty much next.
we use the developer version of Connect for building medical apps, and the news wasn't quite nice when they moved to the version 2, which is very bulky now.
Right.
Pretty power hungry, so it's sort of
Okay.
go away from it.
Yeah, no, I'm sorry.
Now to Intel's RealSense cameras that are now embedded into their newer laptops.
Right. If you are interested, and give me a business card after, and I'll track someone down who can talk more about it. Yep, cool. Alrighty. Okay. Enjoy the rest of your day. Thank you very much. Cheers. Thank you.